Hello, everyone. Welcome to the Developments in Wolfram Alpha Notebook Edition talk. My name is Paco Jane. I'm a research programmer with Wolfram Alpha, and I was responsible for hooking up the demonstrations that you'll see here, and also some of the backend for Wolfram Function Repository items. My two co-presenters are Peter Falloon and Jeremy Stratton-Smith, and they can go ahead and introduce themselves.
Hi, I'm Peter Falloon. I'm a consultant for Wolfram Research based in Perth, Western Australia. My main work has been in the area of session references, which I'll be talking about today, as well as geometry and math input.
Great. My name is Jeremy Stratton-Smith. I'm a math developer for Wolfram Alpha, and my primary area of work for Wolfram Alpha Notebook Edition has been the function repository and hooking up function repository items, as we will see, as I'll talk about in a little bit.
Okay, thanks. So just to remind those of you who may not be aware, Wolfram Alpha Notebook Edition is a product that was created about a year ago. It combines the natural language processing power of Wolfram Alpha with the notebook sort of flow development environment that's so popular these days and has been in the Wolfram language for a long time. So what is, I'm going to start talking about demonstrations. What is demonstrations? So demonstrations, there's something called the Wolfram Demonstrations Project that's been going on for about over a decade, where we've solicited from the public, anyone can submit interactive code that will demonstrate, as the name implies, some it could be anything really. It could be, for instance, here, let's look at this category called algebra demonstrations. And the main part of what is presented here is what in the Wolfram language is a manipulate object. And for those of you who have seen these before, manipulates allow you to change parameters, change variables, and see how your results will change. And this can be very useful in a pedagogical environment in order to show things that, you know, are better shown in a hands-on way. Let me change this to standard form. There's just a little bit of an issue when you're looking at these in traditional form. But let's take a look at one of these things, rotation matrix indices. We've made getting a notebook representation of these things very easy by clicking on these orange buttons you see. And you can see that after clicking that button, I'm going to get a window opened up. Here I clicked on change of bases in 2B. So this is an example of something you might be drawing on a chalkboard in your traditional math class. But of course, in these days, in this day and age, you know, you've got maybe electronic whiteboard, or maybe you're doing a Zoom meeting, and you want to be able to demonstrate these types of things to your students in a dynamic and visually engaging way. So that's basically what a demonstration is. And you can see it comes with text, it comes with related links to other things in the Wolfram world, and also source code, so you could even modify this to your heart's content. These are also available on the wolframdemonstrations.com, demonstration.wolfram.com website. But the nice thing here is that we've got access right here in the Wolfram Alpha notebooks with natural language. Just to show you a few of my personal favorites, you know, I like to think of these as examples of where maybe in your classroom you'd be doing a lab or some other type of group activity that has become harder in our sort of work from home, school from home situation. And this can hopefully help with teaching. So like blood type inheritance, we've all played with these probably in high school or college with inheritance, and you can just simply see how things work. That's what this is all about, demonstrating. I'll just show you another one here because it's kind of like a virtual lab situation. There is an issue when these are presented in traditional form. They don't work so well, but you know, something like this is a nice hands-on sort of thing. All right, moving on. I'm going to talk about another domain, chemistry, which is not somewhere that I've worked directly. We have our Wolfram Alpha chemistry team made of 2 Jasons, and they have developed all of this nice stuff. Sorry, I thought this was going to be pre-populated. And I just wanted to show you these pictures. So, you know, even though Wolfram Alpha Notebook Edition is thought of, you know, you might think of Wolfram as in general a mathematical sort of piece of software, but you can see there's biology, there's chemistry, there's all sorts of interesting stuff that we're adding, and we're adding linguistics so that people have easy access to them. What is the chemical formula of melatonin, for instance? All right, with that, I'm going to hand over the talk to Peter. Peter, I'm going to stop sharing. Go ahead.
Okay, thanks, Baku. So I'm going to now talk a little bit about session references in Wolfram Alpha Notebook Edition. And to illustrate the basic idea, I'm just going to walk through a very simple series of calculation steps, which will kind of illustrate what I'm talking about when I say session references. So to begin, I'm going to define a variable y in terms of a polynomial involving a variable x. Then I'm going to define another variable z also in terms of x. And now what I want to do is a calculation that refers to y and z. And so here I ask, what is y times z? Okay, so this seems pretty straightforward and obvious, but what's going on under the hood here is we're actually making use of the fact that we've defined y and z. So y and z have a definition in our current session. And so when we talk about session references, we're talking about this kind of functionality, the ability to refer to a variable or a previous output. And one final step here, I can say expand this, and the key word here, this, is interpreted as, again, a session reference, this time referring to the result of the previous calculation. So the use of session references, either variables or outputs, is sort of fundamental to the ability to build up a calculation in a series of steps, as this example is kind of illustrated. I'm just going to very quickly talk about what are the kind of linguistics that are supported and some of the issues. Firstly, for locally defined variables, so the y and the z in the above example, it's pretty self-explanatory that if the variable's name is y, that's how you're going to refer to it. However, there's a couple of potential gotchas. Firstly, if you want to define a variable involving subscripts, this is supported. So x subscript 1, x subscript 2. You'll notice that obviously we don't then want to enter that in natural language in the same way that it appears in Wolfram language. So the explicit use of the underscore to denote the subscript is recommended there. A second case that can cause some confusion is whenever your symbol names happen to coincide with built-in symbols in the Wolfram language. So capital C and capital D both have meaning in the Wolfram language as constant and derivative operators respectively. So what we do to get around this, we actually interpret your C and D as scripted characters, and that kind of conversion is done sort of invisibly to you, the user. So you can continue having defined those variables to refer to them as regular C and regular D, and Wolfram Alpha Notebook does the conversion for you. If, on the other hand, you wanted to copy, you know, realistically, the way you would probably end up here is if you had copied an output and pasted, that's also supported. So this is just a kind of a convenience mapping from, you know, regular uppercase characters to scripted ones whenever the regular ones are clashing with Wolfram language syntax. Things are a little bit more varied for references that refer to previous outputs. So here's another example. So, you know, expand something, we might then ask to subtract 1 from this. So again, this is playing the role of a reference to the previous output, and that works as you'd expect. In addition to that, you can also use Wolfram language syntax for referring to previous outputs. So the percentage symbol is probably the most common way to do that. Also relative out references, so out -1 is referring to the previous output. finally out with the number of the input. So here, this previous output was number 14, so I'm going to say factorize out 14, and that should just work. Good. So that's a few different ways that you can refer to previous outputs in your session. Just a quick comment that the Wolfram language syntax is the most precise here, and it's recommended if you're going to start doing things that involve multiple the results of multiple different evaluations. This is the cleanest way to ensure that you get what you're expecting. Just a quick comment on definitions. Obviously, a lot of this session reference stuff relies on you being able to define symbols or functions. One thing that a design choice that was made is that when you do an expression like y equals x squared, that gets interpreted as an equality rather than a definition for y. And the recommended kind of preferred way, if you want to actually insist on making a definition rather than an equality, is to prepend a keyword like let, or also things like define will work. And when you do that, you get a definition for y. Also, if you want to define a function as opposed to just a variable, the thing to do is to put the argument on the left-hand side, just as you would when you're writing mathematical notation. And you'll see here that this gets correctly interpreted as a function definition with the underscored symbol on the left-hand side. Okay, so that's basically session references, function definitions. A lot of the work that's ongoing in this area involves basically trying to make the Wolfram Alpha Notebook programs a bit smarter about how it interprets what your reference is and how it should be used. And a couple of examples to illustrate the kind of issues that are involved here. Firstly, matrix inverses. So let me go ahead and define a 2x2 matrix, and then ask for the inverse of this matrix. And not too surprisingly, the result that you're going to get is the Mathematica or Wolfram Language inverse function. Okay, but what about if your matrix is not square, in which case the inverse function doesn't apply? In that case, we actually are able to recognize that the matrix isn't square, and instead we give you the pseudo inverse function. So that's sort of showing you that the interpretation of what it means to invert your previous result, or in this case your variable m, is a function of what kind of expression it is. Another place in which this is quite important is in plotting. So if I just do some function here, something sine of x squared, and then ask to plot this, the result you get is the Mathematica plot function, which is the right thing given that this is an algebraic expression. However, if instead of an algebraic expression you had a list of numbers as your input, so here I've just done sine of k squared for a range of k values, and you ask to plot that, obviously the plot function wouldn't be much help, and so what we return is the list plot function. And so you can imagine that for, like, there's lots of different things that would necessitate different types of plot function, and so it helps that we have this kind of awareness of what type of result or what type of input you're trying to feed into the plot. So how does this work? I'm just going to give some very sort of basic sort of ideas here to give you some kind of idea of what's going on under the hood, and sort of hopefully help give you some understanding if and when you encounter issues where things maybe aren't behaving as you might expect. So firstly, just the distinction that I think is helpful to draw is there's basically two evaluations going on in the Wolfram Alpha Notebook. The first one is what we call the parsing of your natural language expression. So this involves sending your natural language query to our Wolfram Alpha servers and parsing it just like Wolfram Alpha, using the same engine that Wolfram Alpha is using to convert your natural language query into a Wolfram language expression. Okay, that then gets sent back to your local session where it gets evaluated using the Wolfram language kernel. And so right away you can see that there's a potential issue here, because the natural language conversion is happening on the Wolfram language server and not inside your local session. And that means that a lot of the information, the contextual information about your session, is not available to the Wolfram Alpha server. And so the sort of way that we get around this, the way we make this work, is to actually send a certain amount of information with your natural language query to the Wolfram Alpha server. And for those who are curious, I'm just going to give you a peek at what this actually looks like. So let me define two matrices again, and I'm going to invert each of these just like I did above. See, we get inverse of A and pseudo inverse for B, which is not square. Okay. Clearly, we've sent some information about the matrices A and B in order to make this work. And the way you can find out is the Wolfram alpha function, which has been a part of Wolfram language for at least, I think, since version 7 or 8. You can actually ask for the session info field for this. You get this kind of fairly intractable looking expression here, but the thing to notice is that what is getting sent here is a bunch of different things, and one of them is a list of the relevant symbols. Okay, and we can see the symbol A here. For this particular case, A is a fairly small expression, so we actually send the value of A, which is the complete expression. If A was a much larger list, then this value field wouldn't be sent because it would make our URL too big. In addition to the value, we have the head of the expression, we have dimensions, and we have a list of these things called semantic types. And the semantic types are what really drives a lot of this functionality, because, you know, regardless of the size of the expression, in some cases where the value is not available, the semantic types give us the information we need to sort of intelligently determine which type of function should be returned. And you'll see, just by way of comparison, that for the case of B, the list of semantic types is slightly different. So there's not a, see here, there's a numeric square matrix, a square matrix. In the case of B, which is not a square matrix, we don't have those semantic types present. Okay, so thanks very much. I will now hand over to Jeremy, who will continue.
Fantastic. Thanks, Peter. If I can get the screen share. Quickly. I'm going to be talking about using Wolfram Function Repository items in Wolfram Alpha Notebook. So the basic idea of this is that, as Paco said, in Wolfram Alpha Notebook Edition, we have access to all of the power of the Wolfram Alpha natural language parser, which is really great. But on the website, for those of you who are familiar with Wolfram Alpha, when you give an input, it's very likely that you'll get more than one pod of information out. And we ran into an issue of how do we capture those very specific pods and potentially multiple pods per input into one single output in Wolfram Alpha Notebook Edition. So these sort of highly specific computations that maybe don't quite fit in with the overall Wolfram language design are things that we've been able to wrap up and put into these function repository items. So first here we see we have a plot. This is a very standard sort of calculus thing. Okay, we see two curves and we want to find out what's the area of this little region in between here. So we can ask for the area between x and x squared, which is something that on the web you would not only get this result, but you would also get the plot together. But here, because there isn't a built-in Wolfram language function to compute this using some integrals, we have wrapped that up into this resource function area between curves, which is accessible to anybody, even outside of Wolfram Alpha Notebook Edition, but it makes for a nice concise statement that we are able to compute here. In addition to these highly specific computations, we are also able to provide some summaries of information that are similar to what you might find on the web. So another function repository item, curve fit report here. We parse to this curve fit report, and then we get not only the equation for the fit, but a plot and a whole bunch of other information that a student wanting to, a student in high school or in college statistics class might want to know. So sometimes we have these nicely formatted grids. In other cases, we are returning an association of information. So in this case, we have a number of different forms of this tangent line to the curve y equals x squared. And we have some more information about it, the slope, the intercepts, a plot, and so on. So in this way, we're able to take a sort of complicated or potentially somewhat vague input and return a lot of information akin to what's happening on the web. A lot of these function repository items have also been designed with Wolfram language syntax in mind, so that something like this, where we're implying that we want a dynamic output, not only are we now able to have an interactive output, which is something we can't have on the web, but we're also introducing users to sort of the conventions of Wolfram language syntax, which this manipulate plot merges the syntax of both the plot function and the manipulate function. So you can see our manipulator variables here in addition to our plot range. And then also be able to interact with this in the ways that we aren't necessarily able to do on the web, which makes for great interactive lessons. We're also able to take things like the sort of standard calculus task of identifying all of the interesting points and properties of a curve, and we're able to dynamically do that here with this particular curve analysis function. And we're able to show all of the relevant information, as well as, again, a nicely formatted set of code here that presents all of the things that we're able to see here and more. So we can talk about the domain, the range, period, etc. So in this way, using these function repository items really makes it possible to take a single input and provide as much content as we can, and really make use of the fact that we are working in a notebook, so that there's interactivity available and all of the things that make a notebook great to work with. Similarly, just to highlight, as Peter has already been talking about the session references, these WFRs, or Wolfram Function Repository items, also will work with our session references, so that we assigned this definition to F here, and we're able to get the vertical and horizontal asymptotes out. So that's a little brief overview of the way that we're using these function repository items. These will continue to add support for these over the coming years, and they are a really great way to consolidate the content into a single function and make it accessible to outside users. So for our future work in the next year, you can look forward to hopefully having multi-line inputs. Everything that you've seen here has been a single line per input cell. And so we might be adding support for multiple lines within the same input cell. And additionally, we're excited to be working on adding 2D inputs. So the kind of things that you saw with Peter, where there was the special notation for subscripts. Hopefully soon we'll be able to have the 2D fractions and powers and all of the nice typesetting, particularly for math, that you're able to get in a normal notebook, that will hopefully be able to be input directly into the natural language input cell there. We'll also be developing a demonstrations browser, so that the content that Paco was introducing at the beginning will be made even easier to access, which will be really great. And as the end users continue to interact with Wolfram Alpha Notebook Edition, it tells us what things you all are interested in. So there's ongoing content improvements, because this does rely on the Wolfram Alpha technology. This is constantly improving, and it isn't on the same release schedule as or many features are not on the same release schedule as the Mathematica proper. So we're able to update things much more in a much more live fashion. So as you all use the product, we're able to see what areas need improvement and what you all want. So we encourage you to continue using Wolfram Alpha Notebook Edition. Thank you so much for joining us today, and feel free to reach out to any of the three of us if you have more questions or comments about the presentation or Wolfram Alpha Notebook Edition in general. So thanks, and I'll stop sharing here.